So this is a follow-up video from the previous one in which we showed you how to derive a formula for the general solution. And if you haven't watched it already, I highly recommend you check it out. I'll leave the link in the description. Now in this video, we'll use the same process we used to derive a formula for the general solution, but we will make things more concrete by solving an initial value problem, which is a differential equation problem with which you're given an initial condition for a particular solution. The initial condition in our problem tells us that there is a particular solution y of t that has the value of 1/2 when t is equal to 1. After we have solved for the general solution, we will use this initial value to solve for the unknown constant of the particular solution. The first step of solving this equation for the general solution is to make sure that the equation is in the correct initial form. Now, if you look at our equation, the coefficient of the derivative of y is t, and we need it to be 1, so we have to divide the equation with t. When you do that, you get the derivative of y plus 2 over ty is equal to t minus 1 plus 1 over t. And once we have our equation in the correct form, the next step is to find the integrating factor. And in the previous video, we actually derived a formula for the integrating factor, which we called I of t. And the formula was e raised to the integral of the coefficient of y. And in this case, the integrating factor would be e raised to the integral of 2 over t with respect to t, which of course is e raised to 2 times the natural log of the absolute value of t. And we don't need the constant of integration here for reasons that was explained when we derived the formula in the previous video. But this can actually be simplified further. A constant times a natural log of something is the same thing as the natural log of that something raised to the constant. So this can be the same thing as the natural log of the absolute value of t squared, which actually the natural log and e cancel out, so it's just the absolute value of t squared, or actually just t squared, because since it's a square, it doesn't matter that it's the absolute value because it would always be positive. Now that we have found our integrating factor, which is t squared, we can multiply our entire equation with it, and that will give you t squared times y prime plus t squared times 2 over t would just be 2t times y, and that would be equal to t cubed minus t squared plus 1 over t times t squared is just t. And 2t is the derivative of t squared. So on the left side of this equation now, we have the product rule in terms of the function t squared and y. So that could be rewritten as the derivative of t squared times y, which is equal to t cubed minus t squared plus t. And for our next step, we would have to get rid of the derivative on the left side, so we would have to integrate both sides. And when we do that on the left side, we're just left with t squared times y. And on the right side, when we integrate that, we get 1/4 times t to the 4th minus 1/3 times t to the 3rd plus 1/2 times t squared plus the constant of integration, c. And finally, let's just solve for y of t. So the first thing we would do is we would have to divide both sides by t squared. So when you do that, you get y of t is equal to 1/4 times t squared minus 1/3 times t plus 1/2 plus c over t squared. And this is our general solution for our differential equation. Now that we have our general solution, to solve for a particular solution, we can plug in the values of the initial condition and then solve for the constant of the particular solution. And when we do that, we get 1/2 is equal to 1/4, and t is 1, so it's just 1/4 minus 1/3 plus 1/2 plus c. And now we can solve for c. So subtract half from both sides, that'll give you 0 on this side, then add 1/3, and then subtract 1/4. 1/3 minus 1/4. That is, so c is 1/12. And when you plug that in to the general solution, that will give you the particular solution that satisfies the initial condition. And that solution is y of t is equal to 1/4 times t squared minus 1/3 times t plus 1/2 plus 1 over 12 t squared. And that is the particular solution that satisfies the initial condition. Let's do one more, and feel free to pause the video and try it out yourself. So the first step, of course, is to put the equation in the correct form. So to do that, we would have to divide this equation by t. And when we do that, we get y prime minus 2 over t y is equal to t to the fourth, t to the fourth times sine of 2t minus t squared plus 4t cubed. And the next step is to get the integrating factor, which is e raised to the integral of the coefficient of y. So that would be e raised to the integral of -2 over t. And when you evaluate that, you're gonna end up with t to the -2. It's the same exact thing, almost the same exact thing as the previous one, but in this case it's a -2 instead of a +2. And so of course the next step is to multiply the equation with the integrating factor. So when you do that, on the left side you actually get the product rule in terms of t to the -2 times y. So that can be expressed as t to the -2 times y prime. And on the left would be, when you distribute t to the -2 to the right side, to the right side of the equation, that would give you t squared times sine of 2t minus 1 plus 4t. And so now when we integrate both sides, the left side becomes t to the -2 times y, and on the right side we can actually split it into the sum of two integrals. So it would be the integral of t squared times sine of 2t with respect to t plus the integral of -1 plus 4t with respect to t. So now we can integrate the first one by parts and then add the results of the second one to it. So when we do that, we get t to the -2 times y equal to -1/2 times t squared plus times cosine of 2t plus 1/2 times t times sine of 2t plus 1/4 cosine of 2t minus t plus 2t squared plus the constant of integration. And I actually did the integrating ahead of time because I didn't want to make the video too long. And so when you integrate the right side, this is what you'd get. And the next step would be to divide both sides by t to the -2 to solve for y, which is actually the same thing as multiplying by t squared. So that will give you y of t is equal to -1/2 times t to the 4th times cosine of 2t plus 1/2 times t cubed times sine of 2t plus 1/4 times cosine of 2t 1/4 times t squared times cosine of 2t minus t cubed plus 2t to the 4th plus constants of integration times t squared. And there you go. This is our general solution. So now that we have our general solution, we can work on solving the particular solution that satisfies our initial condition. And we start by plugging into the general solution the initial value and solve for the unknown constant c. And so when we do that, we get 3/2 times pi to the 4th is equal to, now over here cosine of 2 pi becomes 1 and sine of 2 pi is 0, so this whole thing actually cancels out and this will be 1. So it will be 1/2 times pi to the 4th plus 1/4 times pi squared minus pi cubed plus 2 pi to the 4th plus c times pi squared. So now it's just a matter of solving for c. So we can add half pi to the 4th to both sides, and that will give us 4/2 pi 4th or just 2 pi 4th, and we can subtract 2 pi's to the 4th power from both sides, and that will actually give us 0. And then we'll be left with this term right here and this term right here. And so when we take this to the left side, you get pi cubed minus 1/4 pi squared. So we're just basically adding pi cubed to both sides and subtracting 1/4 pi squared to both sides. And that will equal c times pi squared. And then when we divide pi squared from both sides, it cancels out on this side, and over here pi squared. So this becomes just pi, and this goes away. So you're left with c is equal to pi minus 1/4. And so now when you plug this value of c into the general solution, that will be our particular solution that satisfies the initial condition. And so that will be y of t is equal to -1/2 times t to the fourth times cosine of 2t plus 1/2 times t cubed times sine of 2t plus 1/4 times t squared times cosine of 2t minus t cubed plus 2t to the fourth plus pi t squared minus 1/4 t squared. And this is the particular solution that satisfies the initial condition of our problem.